Hey everybody, and welcome back to Jim's Garage. Today marks an important milestone on the channel, and I'm really excited to kick this off by launching Homelab 2.0. I'm going back to basics. I'm going to be building out a new Homelab. I'll provide a guide of all the hardware. That's this video. In the next video, we're going to be deploying our first hypervisor, our first containers and LXCs. That'll be using Proxmox, but I will be talking about other alternatives that you might want to consider. Lastly, I'm then going to go over a full network topology, and I'm not just talking about how I have this set up. I'm doing a full vendor walkthrough with both MikroTik and Unify. I'll go through the complete hardware setup, all the network configuration, and a lot of the security features that you want to go along with that. Things like VLANs, segmenting your network, putting things on DHCP leases, reserving MAC addresses, and a myriad of other things. So this video series is going to be aimed at beginners, but I'm not going to be holding anything back in terms of technical configurations, technical phrases, concepts, all of those sorts of things. I will be explaining those in detail, but I figure it's really important to know those things up front, because especially if you're going to be exposing services, etc., putting your personal data on here, I feel a moral obligation to give you the tools and understanding that you need to make the right choices. I will be making reference to other videos on my channel. Those will largely be around complementary services that you might want to install or additional features that would enhance the common setup. Well, we should probably kick off by talking about what is a Homelab. And to be honest, if you ask different people, it will mean different things. Broadly speaking, I like to coin it as a test bed. It's something that I can have at home that emulates maybe something I would want to do in the workplace or something that I want to learn. So for example, if you want to start learning about setting up services, exposing services to the internet, firewall rules, networking, NAS storage, all of those sorts of things, it's a great start. Also things like development. If you want to have, say, CI/CD pipelines, etc., building things out into testable areas, that's a great way to do this at home, and you don't have to worry about the workplace. It means that you're not going to break things at work, and it also means that you get to play with these features if your workplace isn't supportive of those sort of training initiatives. And probably on a more positive note, I think it's a great way to actually enhance user experience. There are a number of self-hosted Homelab apps that I basically become dependent on. They often offer features that the competitors don't, things that you even pay for, so things like Plex or Jellyfin or NAS solutions like TrueNAS, for example. Those allow you to both keep your data private, but they're also highly performant, and they're great experience to take into the workplace. Things like home automation are another example. It gives you the complete freedom to customize and control your home automation without having to rely on any third-party applications or hardware. I love to use my Homelab to experiment with things like clustering, so setting up a Kubernetes cluster. I don't think that's necessary for everyone, but I do recommend that you set it up and understand and learning. It's great to put it on the CV. So without further ado, let's jump into the topic of this video. How do you get started Homelabbing? What is it that you need? What should you get? What are the options? Now, casting my mind back to when I started Homelabbing, there were a couple of key things that I wasn't sure about. Firstly, should I be buying new hardware or should I be using old hardware? And what actually do I need to get this up and running? Well, again, there's no clear-cut answer, and it's up to you and dependent on what you want to achieve. But let's start with the very bare bones, and then you can build up and go on from there. So what I would recommend is kind of falling into two camps. I do the second-hand market or buying something new off the shelf. Both of them have advantages and both of them have negatives. So let's start with the easiest of those two options, which is just to buy something off the shelf. Now, if you're just starting out in tinkering with Homelabbing, I recommend getting something that's cheap, small, and affordable. That will give you the benefit of A, there's not a big initial outlay. B, you don't have to take up too much size to this. C, you're not going to get some of the quirks and fun stuff that comes with enterprise gear. You're also going to be getting something that's new with a warranty, and so hopefully you can go back to the manufacturer if anything goes wrong. Also, you're probably going to have a number of people that will have exactly the same hardware as you, so you can go onto forums, etc., and hopefully someone can share the answer with you. If you do have an idea of what it is you want to do in your Homelab, for example, you know that you want to run a certain number of services, you know you want to have a NAS, that's network attached storage, you know that maybe you need some GPU compute power in your Homelab, then you're probably falling into a more advanced bucket. For those, again, if we're thinking about off-the-shelf products, you probably will be getting something that is more expensive and more bespoke. So that's a lot of talking. Let's go through a few examples of things that I recommend for getting started out if you're looking to buy your first new piece of hardware. Now, here are some of the recommendations that I have if you're looking to get started that should cover a few of the different budget options. But before we go into this, it's really important to discuss what you're actually looking for in devices, such that if I've missed something or there's something that's better for you, or in the future when these things become dated, the core constituent parts are still going to be important and won't actually change. So the key things really that we're looking for are cores, or specifically the number of cores. The performance is important, but it's less important than cores if you're going to be using something like Proxmox for virtualization and assigning different cores to different virtual machines. The notion of the iGPU or the integrated GPU is also important. It's fair to say that the Intel GPUs are better supported in the home labbing space, and they will give you things like hardware transcoding to common applications, things like Jellyfin or Plex, which is really handy because it means that if you've got devices that can't render the native quality of the file, it will actually then use the iGPU to scale that to something suitable, which frees up the CPU because transcoding is a very heavy process on the CPU. The other important things to factor in are the upgradability of the device in terms of its RAM and storage. Many small devices, thankfully the one I'm showing you isn't one of those, but many small devices will come with a single NVMe slot, which obviously hinders the amount of storage you can have on these devices. Also, as you move further on down the road and you want to store more data on these devices, it's a good idea to mirror these drives so that you've got some redundancy in case one of those drives fails. You should actually enact a 3-2-1 backup strategy, but that's further along the line, and I've already covered that in previous videos if you want to go and have a look at what I'm talking about. It might be worth checking that video out because it might factor into your Homelab buying decisions. It might be better to choose something that covers that base at the start. I will give options for sort of a all-in-one later in this video. Networking is also an important feature that you want to have a look at. Basically, faster, better. That's pretty much it. Now, on the consumer devices, I'm going to show you at the start of this video, and certainly on the cheaper consumer devices, you're going to be limited to just simple RJ45 ports, which is probably what you're most used to anyway, and is going to be most compatible with things like your ISP router. Now, recently, the default has changed, so when I started out, it started at sort of gigabit speeds, but now we're frequently seeing 2.5 gigabit and 5 gigabit NICs. So those are going to give you much better speed, but obviously you need to have support in network hardware to take advantage of that. The number of USB ports are in the nice to have category, but predominantly you're not going to be using much USB connectivity in your home lab. You may have things like Zigbee connectors, etc., but broadly speaking, most of the heavy lifting will be going on inside, and connection wise it's all through sort of PCIe lanes. One thing to note on the PCIe lanes, again, this is a complicated topic. The layout of these devices in terms of how the PCI layout is completely different, so you want to go and check that out. The number of PCI lanes is going to affect how many devices you can attach to a device at full speed. Basically, more lanes is better, but it's not even as simple as that because different boards will have different layouts in terms of how those lanes are actually distributed between physical slots. Also, one thing to note is even if a slot is, say, a 16 slot, it may actually run at a slower speed. And it may not run at the PCI generation as well that you think it does. For example, PCI 4 often runs at a PCI 3, and a times 16 will often run at a times 8. You definitely want to go and check the small print. I'll give some examples of that as we go through this. So with a very quick primer on what to look for, let's have a look at some example devices where hopefully I can try and bring some of that to life. So if we start at the bottom of the stack, I'm going to recommend the Beelink EQ14, and I'm not going to show it, but also a nod to things like the Zima Blade 2, which isn't yet out, but from everything I've seen does look promising. So why do I recommend this device? Well, if we look at it, it's coming in at £269, and you should definitely go and check it out on their official website as well, because often they do run a discount. A great example of that is if we look at the same device on the official website, you can see that it's coming in for $200 here. Now, what's good about this device? Well, let's peel back the surface and let's have a look. It's using the newest N150. This is definitely a bare bones CPU. It's in the budget category. But what's great is it's very low powered, it's cheap, and it has some important features. It has an integrated GPU, and it also has 4 cores, which is going to give you the ability to do some moderate processing on this machine. Now, this device does ship with 16 gigabytes of DDR4 RAM, but that is upgradable. I believe the newest model, this isn't showing the newest one, does support DDR5, and it is only single channel, so there's only one stick in this machine. But from my understanding, you can put 32 gigs of RAM in here. Now, what does that mean in terms of what can I run on here? 16 gigs of RAM is pretty good if you're just starting out. It's going to be able to run multiple containers in a virtualized host, or even something like if you just want to dedicate this whole machine to your Homelab, i.e. bare metal, it's going to be more than enough for starting out. This machine is going to struggle a little bit once you start to put, say, a hypervisor on here. For example, we install Proxmox on this machine. That's going to take up one of those CPU cores really, because you should be reserving CPU cores for workloads. And then that leaves you really with sort of 3 cores left over. You could put that to a virtualized machine. You could possibly put a VM and a firewall on here, possibly a few containers as well, which would be good, but you're going to start to run out of processing power pretty quickly. So do think about what the limitations are and whether they're going to impact you in the near or far future. The good news is this does come with an Intel UHD graphics, which is what I mentioned earlier about those integrated graphics. So what that's allowing you to do is to accelerate some of those workloads with the integrated GPU. Now, this device has both dual NICs and dual M.2 slots, and it also has access to the RAM, which allows you to upgrade it. The benefit of this approach is having 2 network interface cards is great. Not only do you get double the performance because you can put certain VMs through certain ports, but you could possibly even turn this into a simple firewall because you've got something for the LAN and the WAN respectively. Having 2 NVMe drives obviously gives you double the storage potential of having a single drive, and having access to the RAM gives you an upgrade path if you want to add more compatible RAM to it. Obviously, with one stick, you'll have to replace a smaller stick with a larger stick, but at least it gives you an upgrade path. Many of these small devices will be an SBC, a single board computer, where some of the components are soldered onto the machine and thus cannot be changed. It's great to see here that you can change that. One of the things that makes this device better for an N150 than a device that I reviewed is the fact that it's a larger form factor and thus can be cooled better. That is something that you want to consider, especially when these things are going to be running 24/7. Do note that these devices are PCIe 3. As I mentioned before, make sure that you read and understand what PCI versions you're buying, because that will impact the speed of the device. PCIe 3 NVMe drives cap out at about 3.5 gigabytes per second, and obviously it doesn't make sense therefore to go and buy a fast NVMe drive with PCIe 5 and stick it in this machine, because you're going to be limited by the speed of the actual socket itself. Similarly with RAM, make sure you buy the right RAM for this. This supports a DDR4. Putting DDR5 in here is likely not to work. Now, moving up the stack in terms of a pre-built off-the-shelf product, you can't really go wrong with either Minisforum or B-Link in their offerings. If we look here, we've got the Minisforum UM890 Pro. The key differentiator here is that we've moved significantly up in terms of both performance and price. In the previous version, we were looking at around $200 mark. And in this version, we're right up straight away to the $479 mark. And remember that this is a bare bones device. Once you start adding in, say, 32 gigs of RAM, we're ramping straight up to about $650. And now, I appreciate that that is not probably an enticing proposition if you're just starting out and finding your feet and determining whether, well, is Homelabbing for me. But if you consider it from an actual value proposition of what hardware you're getting for this price, it's a pretty good deal. We will obviously discuss some second-hand options later in the video. Now, what you're looking at here is a Ryzen CPU. So in the previous one, we looked at an Intel CPU. Ryzen is made by AMD, and it also comes with an integrated graphics card. This is the 780M, which is a reasonably powerful internal GPU. The problem is the support historically hasn't been that great for AMD GPUs. Due to its historic market share, Intel has always sort of had dominance in that space, so a lot of the services that you'll run will fare better with Intel. However, in recent years that has started to change, with different standards coming in, different protocols, etc. that are working much better with AMD. But do make sure that you check whatever you're wanting to run on here does have support for an AMD iGPU. Other things of note here is we've moved up the stack in terms of the PCI. So in the previous device we were looking at PCIe Gen 3, here we've moved up to PCIe Gen 4. We're still getting 2, which is great, but we also get this mysterious Oculink. What's that? Well, you might think, how am I going to get a GPU in here that's dedicated? You're not. That's where Oculink comes in. So we'll discuss later on some of the benefits of what building this yourself looks like. One of those benefits is obviously you can have a larger case, you can have a full ATX motherboard and stick a GPU in this thing. Now, what Oculink allows you to do is to use something like this little device here, and that's an Oculink dock. So if I actually click on that and we have a look at this device, what this allows you to do, you can probably guess from the layout here, is you would insert a full-size GPU into this slot and then power it through here and connect it to your machine via this Oculink slot down here. The beauty of that is it gives you then a full powered GPU. Well, almost. Oculink generally tends to run at PCIe Gen 4 x 4, so you're not going to get the full bandwidth, obviously, of a x16 slot. You'll get a quarter, but that should be more than enough to get most of the power out of your GPU. You probably want to think twice about putting something like a 5090 through here, but if you're using an older GPU, you should be able to max that out. Remember, as we move up the PCI versions, the bandwidth is doubled. So actually, a PCIe 4x8 should be a 3x8. And actually, a 3x8 versus a 3x16 has been shown to not cause a significant impact on most graphical devices, GPUs, around that time. I know, for example, on my 2080 Ti, the PCI 3x8 and the PCI 3x16, there's only about a 2% performance loss. Both of the network cards on here are dual 2.5 gigs, so we've moved up from 1 gig. Now, Minis Forum do occasionally, and so do B-Link, do versions that have 5 gigabit. So I think the UH125 Pro, which is my next one that we're going to look at. I can't find that readily available, so that is something you'll need to factor in. But that does come with dual 5 gig, which is obviously going to give you double the performance per network card as this one does. For this machine, we also move up to DDR5 dual channel. So now we've got 2 sticks of RAM running at DDR5 speed. DDR5 is not only faster, but it also has on-die error correction code so that memory corruption can't occur on the RAM stick, but it still can occur between the RAM and the CPU. So that is something to look out for. Other nice features when we get up to this price point, we start to get things like Thunderbolt and USB 4, which again opens up possibility of additional peripherals running at high speed if you want that. Around this price point, I did mention we do have some additional devices. So the one I just mentioned was that UH125 Pro. That's weighing in at $555. You get a different CPU here. You get the 125H versus in this one, this was the AMD Ryzen 9 8945HS. This one is a more powerful CPU, hence why the price is up there, but you probably don't need all of that horsepower if you're just setting out. Now, at this price point for 555 is compelling because you're getting 32 gigs of RAM and a 1TB SSD. However, it does only ship to the US, so that is something to bear in mind for us poor Europeans. Again, what's great about this device is the NICs are upgraded to 5 gigabit. You can see that here. And also it has an Oculink port. So similar to before, we can actually then add in a dedicated GPU to do graphics intensive workloads. You could also possibly run this just as a gaming PC, but we're not covering that sort of stuff. To give you some options, we have a similar flavor from B-Link. Here you can see the GTI 13 Ultra. I believe that's about to be replaced with the i14, but I haven't got confirmation of that. That's weighing in at $599, and as you can see from this picture here, we've got that dedicated GPU dock. Now, the great thing about that is the actual machine itself sits on that dock along with the GPU, so it really does form that nice compact package that you could easily sort of store. You don't have to have long wires connecting two devices together. Now at $599, that's a pretty good offer as well. We're getting 32 gigabytes of DDR5 and a PCIe Gen 4 1TB drive. Now this device ships with the Intel i7-13900H, which is what I've got in my MSO1, which we'll cover in a moment, and that's more than enough horsepower for what I need to use. Those CPUs do support up to 96 gigabytes of DDR5 RAM, so that's more than enough RAM than you will need. I recommend starting off with, say, a 32 and then upgrading as you need to. Moving on to what is probably considered to be one of the best Homelab devices, we have the Minis Forum MSO1. Now, this is basically the Homelabber's dream. It comes with a 13900H, dual 10 gigabit NICs, courtesy of SFP+. You can see those down here. It's the two slots here on the left, We have two 2.5 RJ45 NICs, courtesy of these two here. Then we have two USB 4 drives, an HDMI, and a couple of USB ports. What makes this amazing is the network connectivity that you're going to get, plus the performance in such a compact package. It also supports up to 3 NVMe drives, albeit they are all operating at different speeds, so make sure you double check what you need first and that you can actually run that in this device. It supports DDR5 memory up to 5200 MHz, and I must say that I've got 3 of these devices. I've done various videos on them that you should go and check out, and for me, it's been brilliant. I know some people have had issues. I don't know whether that's a case of bad news travels faster than good news, but for me, I've had 3 devices. They've all been solid. I haven't had a single problem with them. Now, when making a decision, I appreciate this is a lot of money. This is just the bare bones. If you're going to be sticking on 32 gigs and 1 terabyte of RAM, it's going to cost you $629. But the beauty of it, obviously, and like with many of these devices that are bare bones, you can pick the components. If you can find those components elsewhere for cheaper, go and do it. I recommend you probably go and do that because you might have a favorite vendor and you can probably get better spec hardware for the same price. Now, it's going to be interesting how the MSO1 survives in lieu of the MSA2. So what I recommend you do is, hopefully there'll be some discounts on the MSO1, because the MSA2 is kind of what everyone's been asking for a long time. It's the MSO1, but with an AMD processor. Now, do note there is an A1, but that's very different to this device. This isn't sort of that mini server, it's more of a mini PC. So make sure you double check that, don't get confused. The A1 is not a lower spec A2, they're fundamentally different. Now take everything that I'm going to say here with a grain of salt, because this has only just been announced and I don't know how sort of final this actually is. It looks final because it's on the website, but do keep a check on it in case this does change. It looks like they're actually coming in at a good price point here of $559. Now, if we add on the RAM similar to the previous MSO1, we go to $719, which is more expensive than the $629. However, this processor here is an absolute beast. It's about 50% quicker again than the MSO1. Obviously, that's just looking at abstract numbers. The real world testing we'll see when that device comes out. What's cool about this device is obviously crazy processing power. You're getting faster RAM support. You're getting the same PCIe Gen 4 NVMe goodness. You're getting the same dual 10 gigabit LANs, 2.5 gigabit NICs as well, and you're getting that PCI times 16 slot. Do note that on these devices, both the MSO1 and the MSA2, that they do not run in times 16, they run in times 8. And also, don't expect to be sticking in a full discrete GPU in here. This is a very small form factor case. There are only a limited number of GPUs that actually fit in here, and good luck trying to get a riser in there and trying to power it. It is possible, but it's pretty complicated. So now I appreciate I've bombarded you with a ton of products there. I'm not sponsored by any of those guys. I will put some affiliate links in below if you want to go and buy it, but I do recommend just checking out their website, not my affiliate links, because they often have better deals direct through their website. Now, there are probably some devices that I've missed out from this, but hopefully now you've got an understanding of what you should be looking for and what some of the competitors out there are offering. It really is a case of making sure you get the best value for your money and making sure that it's got the features that you need. Now, before I actually get onto the custom-built Homelabs, it's probably worth talking about some of the additional things you might want to consider when buying these devices. And we've spoken a lot about networking, and that's definitely one of the areas you want to be thinking about. Now, in its simplest setup, hopefully you could just be able to plug this Homelab, whatever device you buy, into your ISP router, and then you're off to the races. You can access it either directly, just attach a monitor to this thing, or probably more advanced than what you should get used to, over say an SSH connection. Now, when you want to start expanding your Homelab, you're obviously going to need some more peripherals. So you should definitely consider what networking options you're going to go for. Now, as we saw with the N150 devices, those B-Links, those cheaper devices, they only come with either gigabit or 2.5 gigabit. So in the future, those are going to be your limitations on these devices. Things like the MSO1 and the MSA2, those come with 10 gigabit, albeit they're SFP plus form factor. So again, that adds some complication. I'm going to touch on more of the home labbing stuff around networking, firewalls, etc. as we move up the stack. There are various offerings from lots of competitors. I'm going to be focusing on the MikroTik stack because they offer excellent value, and also the Unify because for similar reasons, but also with a great user experience on top. So it might be worth holding out until I've completed this series so that you can fully grasp the size and the variation and all the varying factors that you can put into your Homelab. Anyway, now let's have a look at not off-the-shelf products. Let's have a look at building your own Homelab. Now, for a lot of people, this might actually be the best option. It's certainly where I started out. I had an old gaming PC lying around, didn't know what to do with it. Well, why not make use of it? And again, choose this as your Homelab device. The beauty of this approach is you've got the hardware and you're probably very familiar with it. You know its capabilities, you know what it can and can't do, you know what connectivity it's got. So in my case, it was an old i7, I think a 6700K. It had a 1 gig NIC, it had a couple of NVMe slots, and it had a couple of PCIe slots that I could put GPUs in. That was great because it gave me a large form factor to build in. It was dead easy to service because it's a big ATX board, and I already had all of the equipment I needed. I think I only added in a networking card to get that up to 10 gigabit, and then I was pretty much off to the races. So I recommend looking at what existing hardware you've got, maybe an old gaming PC, even an old laptop, maybe an old Raspberry Pi lying around, and making use of that first. If you can't make use of it directly, is there something you could upgrade in there? Can you get a better CPU, maybe secondhand off eBay? Or maybe can you add in an additional networking card if you need faster networking? Could you put in a PCIe riser card to get another NVMe slot? Those sorts of things. Now, if we do want to go down the secondhand route, it does actually open up probably some other options as well. You can obviously just go and choose some consumer device parts off eBay, but also you can choose server parts. Now, if you're just starting out Homelabbing, I don't necessarily recommend getting enterprise kit. It's expensive, it's loud, it takes up a lot of room, but it is really good for learning. But if you are determined to get something that is enterprise grade, the second-hand route is pretty much your only option. You can get some older hardware now for really reasonable prices. Just bear in mind that these things are loud, they are thirsty in terms of the power draw, and you do need to up your game in terms of understanding how a server works, what it can and cannot do, what you can and cannot fit, proprietary connectors, protocols, all those sorts of things. So one tool I recommend is an open source project called LabGopher. Basically what this does is scours eBay for you and helps you out and gives an indicative say, is this a good deal or not? Now, don't trust this verbatim, make your own decision, but it can point you in the right direction. The cool thing is here is you can basically dial down the thousands of listings of servers and hardware, etc. on eBay using this handy interface. So for example, let's say we want 2 CPUs for our enterprise grade server. We want a pass mark of, let's just say we want at least 10,000 pass mark, and let's say we want at least 256 gigs of RAM. Storage, you choose what you want. Let's say we want at least 8 terabytes of storage, and obviously the region we want to ship it to, I'm just going to leave that as the default. Hopefully now what we can do is search for that. Now, typical at the time of this recording, LabGopher seems to have gone down for the past couple of days. But if we check on eBay, let's have a look at a couple of servers that I generally recommend. Now, for anyone who's been watching my channel in the past, you'll know that I used to have a Dell R730, and I still recommend those. I bought mine at about £500, which I thought was a good deal, and managed to sell for not too much less. But now, a couple of years on, you can see that they're dropping down easily into the 200s and 300s. Now, yeah, there is a 600. Obviously, it depends what this is being shipped with. Higher CPUs, more RAM, more storage, etc. is going to up the price significantly. But for example, if we take something here like a dual 2640V4 with 64 gigabytes of RAM and some SAS capability, that's not bad for getting started. Another example would be this one here with 128 gigabytes of RAM. So immediately you can see that you're getting more RAM and more expansion over something like the MSA2 or MSO1 for a significantly cheaper price. Now the difference is that as time moves on, things like this CPU just simply aren't as powerful or as power efficient as some of the modern offerings. But if you're looking for an enterprise experience, if you want to learn in those sorts of environments, then an enterprise server could be the way to go. But as I said, this is going to require something like a rack or somewhere to store it. It is going to be loud, it is going to be noisy. What it does have though is lots more PCIe lanes, so you can put far more peripherals in here. You've got far more RAM that you can add to it, lots of cheap CPUs that you can add to bulk this out on eBay as well, and you're probably going to get some nice to haves like dual PSUs, etc. So thank you for watching, everybody. Hopefully that's given you an overview of some of the things that you would like to consider when building a Homelab, and also some of the new builds, those new mini form factor PCs that I recommend. Take all of this obviously with a pinch of salt, apply what I've taught you, think about what networking you're going to need, how much CPU power you need, how many PCIe lanes, etc., and then put that to use. Drop down in the comments below if you have any questions, and also make use of the Discord server. There's a ton of people on there that will be able to help you out. And also I'll be explaining more about all of these items as we actually get into the following videos. The next video we're going to be deploying our first hypervisor, spinning up virtual machines and LXCs, and then I'll get on to actually building out full networks. In which case again we'll have to revisit things like network speed, network connections, those virtual machines. We're going to be talking a lot about different types of RAM, CPU usage, and also the speed of the NICs. Anyway, thank you for watching, everybody. I'll see you in the next one. Take care.